Good day everyone. Today I will share to you my Kinematics Calculator. This is an intelligent app. This was created from the MIT App Inventor open platform. And this is 100% free, meaning everybody can access, everybody can upload, and everybody can use this app without compensation. Now the purpose of this app is to calculate the kinematics problem, especially in uniformly accelerated body and a freely falling body. Now, this is for verification of your solutions to the problems in kinematics. You can provide the answer right away after encoding all those data. Okay, but before going to install and to explore this app, we will have some recall to the kinematics principle. Now, we need to recall the uniformly accelerated body and the freely falling body. Now, for uniformly accelerated body, take note that the particle is moving at a constant acceleration. Okay? Now, which means that there must be an initial point and we have the final point of travel. So along the way, the acceleration is constant. That's why we call this as uniformly accelerated body. At the initial point, we have the initial velocity and it is assigned as v naught. And for the final point, we have the final velocity. The distance or the displacement traveled by the particle is it has a distance of is, meaning that is the change in position, wherein the initial point will be the origin will serve as our initial point and the final point has a distance of s. Therefore, s must be a displacement or a change in position. And remember that the acceleration along the way is constant. Okay? And we have the time of travel at any point of particle from the origin. It has a velocity, and it's because of the time interval. So the time interval is t because the time starts from the initial, which means that the initial time is 0 and the final time is t. So therefore t will serve as the time interval. So with that, we can solve for the average velocity. Take note that the velocity average is the change in position over time. And meaning there are 6 quantities involved in the uniformly accelerated body, which means the particle moves at a constant velocity. They are displacement is initial velocity v naught, without subscript v is the final velocity, the constant acceleration is a, and the average velocity is b ab, and the time interval is t. Now with these 6 quantities, we are provided by the formulas, and these formulas are derived from our previous videos. Okay, now take note that the velocity final according to the formula can be computed using by summing up with the initial velocity and the product of the acceleration times the time. Take note the acceleration is constant, while the displacement or the change in position can be computed by summing up by the product of the initial velocity and the time interval and 1/2 of the product of a t squared, meaning that the change in position or the displacement can be computed by VOT plus 1/2 AT squared. Again, the average velocity is displacement over time interval, or the change in position per time interval. And the average velocity, again, by statistics principle, that you can combine or sum up all collections, then divide it by the number of populations. So meaning it should be initial velocity plus the final velocity divided by 2. If we combine the 4 formulas, we can formulate a function of the final velocity with respect to the initial velocity, acceleration, and displacement. Now, this formula says that the square of the final velocity is the sum of the squares of the initial velocity and the product of twice the acceleration and the displacement. So these are the available formula when the problem is under uniformly accelerated body. Okay, when you look at the textbooks, no, in physics under kinematics, the accelerations, the worded problems are mostly on the uniformly accelerated body. So these formulas can be applied, can be used. Now take note, it requires two distinct points of travel in order to solve that problem. And remember that there are 6 quantities: the physical quantities, the initial velocity, the final velocity, the average velocity, the displacement, the acceleration, and the time interval. Now, when you are solving problem, be sure that we have at least 3 out of 6 quantities, which means that you can solve the problem. You can solve the problem, meaning you can provide the these 6 quantities if we have 3 givens. For example, given the acceleration, given the initial velocity, and given the time, then we can solve for S, V, and V average using the formulas. Which means that when you read the problem, be sure to pick up the given and make sure that there were 3 quantities that can be obtained from the problem. Okay, so with that, we can always calculate, no? But take note that the 3 should not be all velocities. Meaning, if given the initial velocity, given the average velocity, and given the final, you cannot solve it. No, make sure that you have only a maximum of at least, or maximum of 2 velocities given. And you cannot also solve the remaining, no, or the 6 quantities if the given are the average velocity, the displacement, and the time interval only. So those are the quantities, no, that cannot provide the whole quantities of uniformly accelerated body. So again, 3 velocities. Our formulas cannot solve the remaining 3. Meaning you cannot solve for T, is, and the final or the acceleration. Or the displacement, the time interval, and the average velocity. You cannot solve for A, you cannot solve for the final velocity, and you cannot solve for the initial velocity. So those are only the givens that cannot be used. Now for freely pulling bodies, this is a special case of the uniformly accelerated body. We call this a special case because still the acceleration is constant, meaning you can use the formula because the principle of uniformly accelerated body should have the initial and final. So the freely pulling body principle is purely a uniformly accelerated body. But this is a special case. Why? Because the acceleration is already given. And that's the acceleration of the Earth. If the activity or the problem occurs at the near surface of the Earth. So we will be using negative 9.81. Negative because the acceleration is downward. And we use the Cartesian to be upward from the origin is positive. So therefore, all vectors upward are positive. Now downward are negative. And take note that the gravity is towards the radius of the Earth. So according to our frame of reference, our acceleration is a negative 9.81. But if you reverse the Cartesian, if you assume that downward is positive, then the acceleration also is positive. But mostly, we assign for the freely pulling body, we assign upward to be positive. So we have to follow this assumption of the Cartesian plane or orientation of our Cartesian plane. all upwards are positive, which means that the displacement upward is positive, but the displacement downward is negative. The velocity upward is positive, but the velocity downward are all negative. But the time interval is always plus. Take note of that. Okay? So, what are the formulas to be used for the pre-leveling body? The answer is the same. You can use the formula, but take note that the acceleration is already given. So, we have to replace in our uniformly accelerated body, change A to G. Meaning, change it to the Earth's gravitational acceleration. And you have to substitute the negative value of 9.81. Okay? So, with these formulas, these are the basis of my designing my kinematics calculator. So these are the formulas used in programming the app or the kinematics calculator. Okay, so let us now explore or have the kinematics calculator. Now this again, kinematics calculator used to calculate the kinematics physical quantities in a uniformly accelerated bodies and a freely falling bodies. Okay, so now how to download? How to download the app? So all you need to do is to look for the extension file, or in the description box we have the APK, how to install the APK installer for the kinematics calculator. So all you need to do is to click it, and after clicking, I need to open my cell phone first, so for a while. Okay, then start now. Okay, then once you click the APK on my extension file, you will be navigating to my kinematics calculator 2021. So when you click it, it will be downloaded, and there is a notice of scanning. So all you need to know now, mostly of the calculator or the cell phones, once this was installed, the calculator says that there is a malicious files, but don't worry, this was tested, no virus. All you need to do is to ignore, continue. Then if your device block this installation, then all you need to do is to allow restriction. Okay, then after that, once completed, then this will be the appearance of your cell phone. So you can see the image here. So the image is our kinematics calculator. Okay, so once you click it on the icon, it will pop up the environment of the calculator, the kinematics calculator. So this is kinematics calculator, Isasidon, and this is an intelligent app created by Marlon F. Sasidon, Visayas State University by City Elite. And the purpose of this is to calculate problems in uniformly accelerated body. So all you need to do is to read everything. Read everything on the description of this app. So we have here the diagram for the input or output box. We have the VI as the initial velocity. We have the ACC, means the average acceleration or the constant acceleration, and the time interval as time. Then the DIST or dest is the displacement of the particle, and the BF is the final velocity, while VAB is the average velocity. Okay, now to start this app is to click the start button. Okay, all you need to is to click start, then it will pop up the 6 quantities. These are the 6 quantities, the 6 quantities of the uniformly accelerated body. We have the initial velocity, we have the ACC as the acceleration, the time is time, then we have the displacement as a dist, and we have the BF as the final velocity, and the V as the average. The units are all in SI. Okay, so now all you need to do is to input 3 given. You must have 3 given. Now if you don't have the 3, then it will not calculate, so you have to provide the 3. Remember that the uniformly accelerated body problems requires 3, at least 3. So for example, given the average, given the initial velocity, the problem says that the car starts from rest, which means that the initial velocity is 0. So all you need to do is to click this box, then feed in with 0. Okay, then suppose the problem says that the particle is accelerating by 4 meters per second, then click the ACC or the acceleration, and be sure that the unit should be in SI, or it should be meter per second squared. If not, you need to convert it first before going to encode. So let us say this is 4 meters per second accelerating, which means that the particle speeds up from rest. Then suppose the problem says that compute the final velocity. Okay, the final velocity during the time of 5 seconds. So you have given another given time. So take note, the time should not be non-zero value. So in this case, the given is 5 seconds. So meaning the initial velocity is 0, the acceleration is 4 meters per second squared, and the time is 5 seconds. What is the final velocity? So with that, you can now answer by clicking the calculate button. So once calculated, you can see the yellow color. The yellow colors are the calculated quantities. So meaning it calculates the displacement after traveling 5 seconds with the acceleration of 4 meters per second squared, starts from rest. So the calculator says that the displacement is 50 meters. Okay, and the final velocity is 20 meters per second squared, and the average velocity is 10 meters per second squared. So therefore, it calculates everything. So you should input at least 3 in order to compute for the other 3. Okay, now if you want to recalculate again, just click the reset button, then start again. Then suppose given the acceleration as let us say 3 meters per second squared, and the distance is let us say distance of travel is 40 meters. Okay, then the problem says that the final velocity, let us say the final velocity is 42 meters per second squared. The question is, what is the initial velocity? Okay, so then click the calculate button, and the answer says that the initial velocity is 39.03 or 04 meter per second. Okay, it also calculates the time. No? Take note that the yellow are the computed, the black are the input values. Okay, so remember that in uniformly accelerated body, there were only 6 physical quantities. 6 physical quantities. So be sure to have 3. Now in a freely falling body, all you need to do is to use the diagram, no, that I presented a while ago. Now take note that the acceleration is already given. So once you start, you can fit in the negative 9.81 meters per second squared. This is constant, but every time you calculate, you have to feed in the 9.81. Okay, then you can place any number. Suppose it has the height of 10 meters, then what is the initial velocity? No? What is the initial velocity with this configuration? So there were only given two given. No? We have the acceleration negative 9.81, the distance of 10 meters, and you are asked to find the initial velocity that has a displacement of 10 meters. So take note that the highest point of the travel in above the surface, the maximum or the highest the final velocity at this point is 0. So all you need to do is to click the final, then feed in a 0 number. Okay? So with this, there were already 10 or 3 givens. So all you need to do is to click the calculate button. Then with that, you are given the calculated quantities. The yellow again are the calculated. So this is very easy to use. Okay? So according to the problem, that the initial should be 14 meters per second to arrive the displacement of 10 meters. So actually you can use this to simulate problems. This can be used for experiments in a freely falling body. Remember, those are activities that that can be observed in our everyday life. Okay, so now, in order to have the... Okay, so again, it is to remind that in Kinematics Calculator, these are the variables where the VI is the initial velocity, the ACC is the constant acceleration, and the time, TIME, is the time interval, while the DIST or DES is the displacement, and the BF is the final velocity. And we have the average velocity as BF. So we have this figure. So we have to follow. Once you use this calculator, you should have this figure. Okay. So let's do it again. But this time we will solve problem. Just like if you are taking the exam. So once you are given the problem. So for example, UEB, or uniformly accelerated body problem. So let's open again our calculator. So the problem number 1 says that what velocity is attained by an object which is accelerated at 3.3 meter per second squared from a distance of 50 meters if its initial velocity is 0.5 meter per second. Follow-up question, calculate also the time of travel. So there were 3 unknowns. Now take note, the problem is this belongs to what? This belongs to uniformly accelerated body, because the acceleration is 0.3. It signifies that the acceleration is constant. So with that, we can use the calculator. Okay? Take note, uniformly accelerated body or freely falling body are problems that can be solved on this calculator. Okay, so all you need to just to click the start again, click the start button, then it will pop up the inputs. So what are the inputs? The inputs are the acceleration. So click the ACC for the acceleration, then type in 0.3. This is meter per second squared for the acceleration, and the distance given is, problem says it is 50 meters, and the initial velocity is also given. So click this, initial velocity 0.5 meter per second. So again, let us review that the acceleration is 0.3 meter per second squared, and the problem says that it has a distance of 50 meters, and the initial velocity is 0.5 meter per second. Then we are now ready to calculate. So once you calculate, then it will give us the answer. So for the question, what velocity is attained, meaning it is the final velocity, and the calculator says it is 5.5 meter per second. Okay? Diba? Okay. Now, the follow-up question, calculate also the time of travel. Then the calculator says it is 16.67 meters per, or 16.67 seconds. So this is the time of travel. Okay, so this is it, no? Very easy. But take note, when you take the exam, you need to provide the solutions. So all you need to do is to use the formulas, no, we discussed previously. Then provide the solution. Then if you want to verify if your answer is correct, then use this calculator. Okay, this is the purpose. The purpose of this calculator is to verify your answer. Do not depend on this calculator, because the process, the solutions will convince that you are fully understood with the topic. Okay, next problem. So let us solve problems in freely falling body. So it's a worded problem. Now the problem says that an object is dropped from rest at a height of 15 meters. So take note, it was dropped. So it is a freely falling body. It is a free fall problem. So it was initially at rest. So meaning when you start it, the initial velocity should be zero. The initial velocity should be zero. Then take note, this is freely falling body. So all you need to do is to feed in the negative, no? Negative 9.81. This is meter per second squared. So this is always given. Why? Because the problem is free fall. So the Earth's gravitational acceleration is 9.81. It is a constant. But when the problem is in the moon, so you have to use the gravity of the moon at 1.67. So change your 9.81 to 1.67. But if there's no location, no, given to the problem, assume that it happens on the Earth. So you have to use the negative 9.81. Okay, so we need one other. Now the problem says, letter A, find its velocity after 2 seconds. So with that, you can feed in the time. Then you have to encode the 2 seconds. So again, make sure that the unit is in SI. The units are in SI. If not, then you have to convert it to SI system. Now there were already 3 given. So all you need to do to click the calculate button, then it will pop up your answer. Now take note that what the answer says, the final velocity is negative 19.62, and we are given actually also the distance. But the problem, letter A, you're asked to solve for the final velocity. Okay, now when you look at the problem, there's a given of a height of 15 meters. Okay, but we did not use it. Why? Because in letter A, you're asked to find the time or the velocity, the final velocity in 2 seconds, which means that the 15 is not your displacement. Instead, based on this problem or answer, the displacement from initial point is negative 19.62. Why negative? It's because that the displacement is downward. Remember, all upwards are positive. That's why the acceleration is negative, because the acceleration is always downward. And the displacement, that negative 0.62, means the displacement is downward. And the final velocity is also negative. Why? Because the velocity is downward. Okay? So, and we have also the average velocity. The average velocity is negative 9.81. But it was not asked in the problem. Now, problem or letter B, question. Find the time it takes for the object to reach the ground. So you are asked to find from start. Once you drop the object, it will move downward because of the acceleration, and it will speed up. Diba? From 0, it will accelerate to increasing number, but it is negatively until reaches the ground. And the ground, remember, from your starting point must be 15, which means that the 15-meter height can now be used for this problem in letter B. And in letter C, when you look at letter C, this is a follow-up question in letter B. With that velocity, with what velocity does it hit the ground? Meaning, what is the final velocity? Okay? So to answer is to, again, click the start button. The initial velocity is 0. The acceleration is negative again. Negative, this is negative 9.81. And the time, by the way, the time is not given because you are asked for the time. Instead, you can now use the 15. The 15 meters, but that 15 meters should be negative. Why negative? Because it is below. It's below the initial. If that above the initial point, then you can use the positive. Which means that you have to, solving the problem should be, you should know where is your initial velocity, no, directed. But in that case, because it starts from rest, so automatically the object will move downward. Okay, so the given again, the initial velocity is 0, the acceleration is negative 9.81, and the distance is negative 15 meters. Then we are now ready to calculate. I think this is already 15. Then calculate. So the answer is, in letter B, find the time it takes for an object to reach the ground. The answer is 1.75 round, approximately. No, you can round up to 2 decimal places. So 1.75 seconds is the answer. Then the final velocity in letter C, with what velocity it hits the ground? The answer is 17.16 meters per second. Okay, so that's it. No, very easy to use. And the average velocity, even though it was not asked to the problem, but our calculator provides the average acceleration of 8.58 meters per second. Okay, so this is very useful. And take note, this is for free, 100% free. So all you need to do now is to, in the description box, click the APK, then install and explore and use it without compensation. Okay, so thank you.